All right, this little exercise is going to help us understand the decision to locate a factory near an input source or an output market. Okay, so the setup that we have down here at the bottom is that we have the location of the input at a particular geographic space, and 20 miles from that input sits the market. Okay, so our job is to figure out where we're going to place the factory. Should we place the factory here? Should we place the factory here? Should we place the factory here, or all the way at the other end? Okay, so where are we going to put the factory in such a way so that our costs are minimized, our total procurement and distribution costs are minimized? We'll talk about what those terms mean in just a second. The setup is that our input weighs 20 tons, our output weighs 10 tons. In a purely physical sense, this is a weight-losing process. However, when we add the transportation costs to the picture, we see that the input is cheaper to transport quite a bit than the output. And that could happen, for example, if the output is more fragile, requires additional handling or packaging, and that could drive these costs higher than these. Okay. What we're going to do is we're going to combine the weight and the transportation cost per ton per mile in order to get what we call the monetary weight. Okay, so this $20 is the product of 20 times 1, and that's called the monetary weight of the input. And the monetary weight of the input tells us how much it would cost us to move our input 1 mile. Okay, so if we located our factory 1 mile away from our input source, then we would have to pay $20. If we located it 2 miles away, we'd have to pay $40 and so on. That's called the procurement cost, the cost of procuring the inputs for the factory. Similarly, we can multiply the output weight times the output transportation cost per ton per mile to get the monetary weight of the output. And that monetary weight of the output is really the cost of moving the output 1 mile. So what I want you to imagine initially is that we locate our factory exactly at the source of the input. If we locate exactly at the source of the input, there is no cost of moving the input because there is no distance between the input and the factory. So that blue dot right now is the location of the factory at the moment. That's what we're imagining. So the only cost we have at that point is the cost of moving our output, and the cost of moving the output, if our location of the factory is at the source of the input, is going to be the distance between the factory and the market, that's 20 miles, times the monetary weight of the output, or what we call the distribution cost per mile. So if we multiply 40 times 20, that's the distance we have to move our final output to get it to the market, we're going to have a total distribution cost of $800. We're going to have a total procurement cost of $0 because the input sits at the location of the factory. Okay, so what we're plotting in this picture, and this is the part you need to get straight, what we're plotting in this picture is the cost of procurement and the cost of distribution associated with each possible location of a factory. Okay? For the moment, let's consider only the distribution cost. If we move our factory progressively closer and closer and closer to the market, we're going to have less and less distance that we have to transport the output, and so our costs are going to fall linearly to 0. Okay? So if we think about moving the factory to the right, our distribution costs, I'll abbreviate it DC, will fall as we go from left to right because we're moving the factory closer to the market. However, as we move from left to right, something else is happening, and that is we suddenly have cost associated with moving our inputs to the factory. So if I move this way, my factory is located a little bit farther away from the input source, I now have to pay some procurement cost as well. The maximum amount of procurement cost I would have to pay would occur if I located all the way down at this end, because then I would have to move my inputs. I would have to move my inputs all the way from here down to here. Okay. Well, every time we move 1 more mile away from the input source, that is, our factory is a mile more away from the input source, we incur an extra $20 in cost. Once we are at the maximum of 20 miles away from the input source, we would incur a cost of $400 in procurement. And we have a linear relationship that would look like this. Okay? Of course, a firm isn't really interested in either the input cost, that is to say, I shouldn't say input cost, but the procurement cost, or the distribution cost. They're interested in the sum of the procurement and the distribution cost. So if we move from left to right and we add these two vertical distances together, okay, if we add them together, we would end up with a curve, a total cost curve that looks something like this. Okay, so what I've represented here is the total cost of procurement and distribution. So we might call it DC plus PC, and that's this top line right here. What is the firm going to do? It's going to choose the location where the total cost of distribution plus procurement is minimized. In this case, that's going to be locating the factory near the market. How do we know that, without drawing this whole diagram, that that's what the firm would do? Well, as it turns out, we can simply look at the monetary weights of output and the monetary weights of inputs. And if the monetary weight of the output is bigger than the monetary weight of the input, we're going to want to locate near the market, because it's going to be more expensive to get our output to the market than it is our input to the factory. If that were reversed, okay, you would see this diagram tilting in a different way. Instead of tilting this way, it would tilt upward, and we would locate the factory near the input source.